Okay, so now let's discuss about partitioning and sharding. So considering our previous example of e-commerce or the Amazon, so now over the years, the user base will grow, right? And as the users will grow, the number of transactions and the number of orders will also grow. So here, to make you understand, we'll just take example of one table. Okay, so in a database, we'll have multiple tables like orders, transactions, products, right? So here, let's just take the example of transaction table. So when the user grows and the number of transactions grows, the number of transactions like in the table will also grow. So the table size will grow within that database. And now here, after over the years, let's say if any customer or the user comes back and he wants to view his transactions, then the query executed on the database will be will need to scan a larger data set, right? Because the number of transactions has grown over the period of time. So the response to those queries or the API will be higher. So to make it less or to improve the efficiency of the response, we need to go with the option of partitioning. So now what do we do in the partition? So in the partitioning, within the same database instance. So here, let's say we initially have a database of, let's say, 20 GB, and in that, let's say 10 GB has been occupied by different tables, and let's say in that let's consider that the 10 GB is occupied by transaction table only. Okay, so now because the response time has increased and we want to make the response time efficient, we are going with the option of partitioning, where what we'll do, we will divide this table on some partition key into multiple tables like this. So for example, we can have the partition key as transaction date also. So we can just divide the table into different dates. So for this one date to another date, we can have in the first table and second and the third, right? So like that, we can just divide the one larger table into multiple smaller tables, and this division is called partitioning, and this is happening within the same database instance, right? So here, post the partition and before the partition, the size of the database or the data remains the same. Okay, here we are going ahead with partitioning only for the good response time and increase the performance of the overall API. Okay, so this is about the partitioning. Now here, when will we have a issue? So here, though, we got the efficiency for the query response time, but now again, after a couple of years, within the same database instance, as the data will grow, so here we have a limit for increasing the vertical space of an application of a database. So vertical scaling has a limit. We cannot grow beyond some data, right? Because it's at the end of the day, it's a physical server where we can have some upper limit or upper cap of increasing the configuration of an application, right? So now in this case, over the period of time, when this data let's grow around 18 GB or 19 GB, then we need to go for another option that is nothing but the sharding. So in the sharding, what we will do, we will just create another instance of database of the same size or whatever we needed, and then we will just transfer some amount of data into, or we just divide that existing data into two different instances of database. So that is the core difference between partitioning and sharding. So in the partitioning, we were dividing the table into different tables within the same database instance, but in the sharding, we are altogether creating separate instance of a database, and then over there we are dividing the data. Okay, and in both the situation, in both the scenarios, we need to make major changes at the application level, right? Because earlier we just had one table or one database, so we were just directly hitting that table or database. But now when we partition the data, or when we have sharded the data into multiple instances, we also need to make changes at the query level, so that whatever the key that is related to one database, so those queries should go to that database and other set of queries should go to the another database, right? So these changes has to be done, and sharding is considered to be the last option, because when we cannot scale the single instance vertically further, then we definitely need to shard the existing database. So, and it also comes with other advantages, like the overall database load get distributed, and the overall API response or the database response also improves, but it also increases the overhead at the application side, because here in a database we just don't have a single table, right? We'll have multiple tables, and there are many tables which are interrelated. They have dependency on the other table. So if we are dividing any one table, then we need to also divide the data into other related tables as well. So when we shard, we need to take care of all the tables, and that the same effect also will be there on the application side, right? So always in any organization, the sharding is considered to be the last resort when we can't scale further the single instance, because that has a significant overhead on the application side. Okay, so that's the major difference between partitioning and sharding. Here sharding can be considered as an option of horizontal scaling. Okay, and we have already discussed what is vertical scaling. So overall, I hope you got an idea of how to scale the database and in which option we should go with vertical scaling and in which scenario we should go with horizontal scaling. Okay.